first of all, I wanted to start with the discussion about certain special aspects of the parallelogram law of vector addition and subtraction, which we have discussed earlier also. But okay. So going back to the recap. To parallelogram law. For addition and subtraction. And certain special cases of its application. I know that all of you are familiar with parallelogram law already, but let us look at how we can, in certain special cases, we can apply it in a more convenient manner, and we can apply sort of shortcuts by its application. So let's look at the statement of parallelogram law first of all, that if two vectors A and B are drawn from a common origin, so we place the two vectors A and B from a common origin like this, okay, and we construct a vector parallelogram by drawing two parallel sides, make it a closed figure. Okay, so this side parallel to A and that side parallel to B. Then, and of course, the angle between these two is theta. So the sides are of length A and B, and the angle enclosed between them is theta. Then we know that by statement of parallelogram law, the primary diagonal, that is the diagonal from the origin, from the common origin to the opposite vertex, that becomes the resultant sum. Okay, so this becomes the addition of A and B, this particular vector, and the other one here becomes the difference. So if the difference vector is the secondary diagonal pointing from head of B to head of A, then it represents A minus B. Whereas if it is pointing the other way, from A's head to B's head, then it becomes B minus A. So these are the standard statements. And of course, this angle we generally denote by beta, and this angle we generally denote by alpha. So also we know the numerical formulae that are related to this. So given that capital A, capital B and theta are known, we can find magnitude of A plus B by the triangle law formula, which is common to the parallelogram law, A square plus B square plus 2AB cos theta. You can find tan alpha as B sin theta upon A plus B cos theta. And of course, alongside this, we can also see that A minus B becomes root of A square plus B square minus 2AB cos theta, and tan beta becomes B sin theta upon A plus B, sorry, A minus B cos theta. So these are the formulae that you've been used to applying, and you're very familiar with this formula and all that. But today we will look at the application of this in certain special cases when the vectors involved have a certain special kind of relationship. Okay, so this is where the new thing starts. So special cases of application of parallelogram. So the first case we will see is magnitude of A plus B is equal to magnitude of A minus B. When does this occur? So in terms of parallelogram, it means that the diagonals should be of equal length. Okay. And that basically means that the parallelogram in concern must be a rectangle. Very good, 90 degrees. Okay, it must be a rectangle, which means that theta must be 90 degrees. Okay. So that is the first special case in which our parallelogram now collapses into a rectangle, because theta is equal to 90 degrees. That's the only situation in which it is possible where the diagonals will be of equal length. Okay. So now you understand the full implication of this principle here, that it is both ways. If statement 1 implies statement 2, then statement 2 also implies statement 1. I'll explain what I mean. So the length of the two diagonals are equal. It has to be that it is a rectangle. It cannot be any other case, which you can see algebraically also. But the easy way to remember, yeah, I'll give you time to note down. Don't worry. So today's lecture will involve a lot of theorems and writing down notes and all that, with less of questions and more of understanding more things in theory. So this basically shows here. So from this geometry, we can understand that if mod a plus b is equal to mod a minus b, it implies that theta is equal to 90. Okay, why? Because diagonals are equal only for a rectangle. Okay, or that is a parallelogram with theta equal to 90 degrees, or vice versa. Okay, so that also means if theta is equal to 90 degrees, it automatically implies that mod a plus b is equal to mod a minus b, because a rectangle definitely has equal diagonals. Okay. So this relationship, that mod a plus b is equal to mod a minus b and theta equal to 90 degrees. Okay. This relationship is a unique relationship. Okay. That means no other angle is possible for which this will happen. Or for theta equal to 90 degrees, it cannot be that mod a plus b is not equal to mod a minus b. There's only one case possible, and that case is that the diagonals are equal. Or if the diagonals are equal, there's only one case possible, that theta is 90 degrees. So that's one thing where we don't need to apply the algebra. If you go by the algebra method, you will see that mod a plus b equals to mod a minus b. You can also understand it algebraically, that root of a square plus b square plus 2ab cos theta is equal to root of a square plus b square minus 2ab cos theta. Then square both the sides and solve this and all that. So you get cos theta is equal to 0, which means theta is equal to 90 degrees. But this is not what we are doing over here. We are trying to understand this geometrically. And geometrically, this becomes very easy to remember. That you just ask yourself that in which situation mod a plus b is equal to mod a minus b. It's only possible when the diagonals are equal in length. So when are the diagonals equal in length for a four-sided quadrilateral or for a parallelogram? Which type of parallelogram has diagonals equal? And the answer is straight, that only when this angle is 90. So the parallelogram has to become a rectangle. Okay. So this is the first of the special cases. Just make a note of this. Okay. So this is what we are discussing today, certain special cases of parallelogram law. We are starting with that. Yes, Dushant, it can also be a square, but then square is like a subset of rectangles, you can say. We can say the square is also a type of a rectangle. So the necessary condition is that it should be a rectangle. It may be a square, it may be a rectangle with unequal lengths, side lengths. Okay. But the angle has to be 90 degrees. So that's the necessary condition for the diagonals to be equal. Okay, so finished with this part. Okay, good. Now the next thing to understand is in one case you look at a parallelogram where the angle between these two sides, which are the vectors A and B, is an acute angle. So this is theta less than 90. So how this parallelogram looks, just understand the geometry of it. In relation to, now compare this with a situation where the angle between A and B, or these two sides, is an obtuse angle greater than 90. Consider this case. So immediately, without doing any algebra, you will recognize that in the first one, it is the sum which is larger. Yeah, this is continuation of the first thing. It's a continuation of comparison of A plus B and A minus B for acute and obtuse angles. So geometrically, you can see now in this that which is the longer diagonal is this one. Is the primary one is the longer diagonal, and the secondary one is the shorter diagonal. So geometrically, you can see it over here that A plus B is going to be larger than A minus B in magnitude when theta is less than 90. Whereas the moment theta becomes greater than 90, which is this case over here, you can see here that the primary diagonal which is the longer one. So the moment theta becomes obtuse, you can see the parallelogram is stretched in such a way that this diagonal, the one which represents head to head, or the difference of the two vectors, is longer in length than the one which is from the common origin to the other side. So this is a nice visual way to remember this condition. That when theta is less than 90, magnitude of A plus B will be greater than magnitude of A minus B. In fact, also A plus B will have a magnitude which is greater than root of A square plus B square, whereas A minus B will have a magnitude which is less than root of A square plus B square. Whereas the moment theta becomes obtuse, is the other way around. A minus B is greater than a plus b length. And in fact, a minus b has a magnitude which is greater than square root of greater than square root of a square plus b square, whereas a plus b has a magnitude of less than root of a square plus b square. Okay, why that happens? Because cos theta becomes a negative quantity. Over here, cos theta becomes a positive quantity. Whereas, just going back earlier to this case, this mod a plus b is equal to mod a minus b, which is in fact equal to how much? That is, you can add this point over here. It is equal to root of a square plus b square, because cos theta is 0 or theta is 90 degrees. Okay. So you can see the comparison of the two shapes, and it's easy to understand why these conditions are satisfied for acute angle and these conditions are satisfied for obtuse angle. Okay, so this is a continuation of the first case only that we are talking about. But now instead of theta equal to 90, we are comparing acute and obtuse thetas. We are understanding the properties of those two different situations. Yeah, so see what you know from triangle law, triangle inequality. कि जब cos theta positive होता है, then mod a plus b is greater than mod a minus b, and mod of a plus b is also greater than root of a square plus b square. Because mod a plus b is root of a square plus b square plus 2ab cos theta, and when theta is acute, cos theta is positive. Similarly, when theta is obtuse, cos theta becomes negative. So mod a minus b actually becomes larger than mod a plus b because cos theta is negative, and that's why mod a minus b is larger than root of a square plus b square, and vice versa. Okay. Now this thing is very easy to understand just visually when you visualize the two types of parallelograms. One is the parallelogram where theta, the angle between A and B, is acute. So you can see the way the parallelogram is squeezed. The primary diagonal, the one which represents the sum, that is the longer diagonal, and the secondary one, which is head to head, that is the shorter one. So that condition on the two things, A plus B and A minus B, becomes very obvious if you just visualize the parallelogram. Similarly, squeeze the angle theta more than 180, more than 90. You can see it's happening the other way around. Now the shorter diagonal is the sum one, and the longer diagonal is the difference one. So these, okay, so theta greater than 90 implies that mod A minus B is greater than mod A plus B. Becomes very obvious by visualizing the diagram. Is it clear, Arvinda? Yeah. Okay, so for example, if I just put a question like this now, that magnitude of the vector E is 12, magnitude of the vector B is 16 and the angle between them okay, theta is greater than 90, less than 180 degrees. Okay. Then A minus B may be which of these is possible? Maybe which of these? नहीं अमन think again. A minus B पूछा and theta is obtuse. See here, theta is obtuse, na? That means what? Cos theta is negative. Okay. So basically, if you go back to this, you can understand that it's this case. So mod of A minus B is actually greater than root of A square plus B square. Okay. Now you can see here that the root of A square plus B square is how much? It is 20. Okay. And theta is obtuse. So the moment theta is obtuse, you can see that mod of A minus B will be the longer diagonal. So it will be greater than root of A square plus B square. Okay. And its mod of A plus B, which will be less than root of A square plus B square. So since we were asked to find out this, it cannot be this because this is root of A square plus B square. It can be this, it cannot be this, and it cannot be this because here the sum of their magnitudes is 28. Okay. So A minus B has to be less than 28. It cannot be equal to 28 because theta is less than 180 degrees. Okay. अगर theta 180 होता, if theta was equal to 180 degrees, then A minus B would be equal to 28. So if theta is less than 180, accordingly, it has to be less than 28. But anyway, 32 cannot happen in any case. Okay. So which is the right option here? Option B is the only one. It may be 24, but cannot be 20 because for 20 the angle theta has to be 90 degrees. Okay. Cannot be 18 because for that theta has to be less than 90 degrees, and cannot be 30 because that's not possible for any theta. You understood the connection of what we just learned with this type of question, because in this type of question you can't directly put a formula to calculate because we don't know theta. So you have to be a little clever over here. You have to understand these things, that it may be का मतलब क्या हो रहा है ना? So in what condition it can be 24, in what condition it can be 18, in what condition it should be 20. Understood now all of you this question? Anybody has a doubt? Okay, good. So trust you've taken down the question and understood this. अच्छा, similarly इसमें अगर मैं a plus b की बात करता हूँ, if I was talking about mod a plus b, then which of the following is possible? 20 not possible because theta should be 19. 24 not possible. Okay. 18 would have been the possibility. Okay. 30 would have again been not possible. Okay. Because now mod a plus b, because theta is obtuse, theta is greater than 90. So mod a plus b has to be less than root of a square plus b square. So it has to be less than 20. Okay. So that out of these four only this is possible. For the sum of the two vectors, only 18 is possible. For the difference of the two out of these values, only 24 is possible. Okay, so hope this is clear, people. Okay. Now moving on to the next special case, okay, of the parallelogram. Now this one is particularly useful. It's very important. Okay. If magnitude of A is equal to magnitude of B, suppose that is some A. So that means the parallelogram is a rhombus. Now rhombus has certain important properties which you should remember. Properties of a rhombus. So first important property is that the diagonals bisect each other perpendicularly. The second important property is that the diagonals are angular bisectors of the sides. And therefore, the third property, the diagonals cut the rhombus into four congruent triangles. Okay, so let's understand each of these statements properly. Let's understand these statements. So I'll just draw a rhombus and show you what we mean. Then we'll come back to the vector parallelogram becoming a rhombus. So here I'm just talking about geometry. I'm just drawing a rhombus. Whether you draw a rhombus like this, like I'm drawing here, or you draw the rhombus like this, doesn't matter. Whichever way you choose to draw the rhombus, the important property of the rhombus is that the diagonals will bisect each other. Okay. So basically, if a rhombus, so rhombus is basically what a rhombus is, a parallelogram of equal sides. It's a parallelogram of equal sides. So if all these four sides are equal, then additionally what happens is that the diagonals have to cut each other perpendicularly. Then the diagonals have to bisect each other. So this has to be equal to this. This has to be cut in two equal halves. This diagonal will also be bisected by the other diagonal. Okay. So that also has to happen. And more importantly now, these two angles have to be the same. So if this whole angle was theta, it has to be cut into theta by 2 and theta by 2. And likewise, these two angles will become equal. This angle will become equal to this angle, and this angle will be 90 minus theta by 2, as will this angle. Okay. And therefore now you can see that these four triangles, this triangle, this triangle, this triangle, and this triangle, they are congruent triangles. Okay. So those are the three important properties, geometrical properties of the rhombus, which I have listed out above, which I am showing in the diagram below. Now, what is its implication on vectors? I will discuss that. We are coming to that. Okay, but first of all, you should know this as something very obvious to you. You should not get confused between what is the special property of rhombus versus what is the special property of, let's say, rectangle, or what is the special property of square. You should not confuse between these. So यहाँ पर भी ये होगा, as long as these four sides are equal, okay, always this angle will get bisected. As with these two angles. And also these diagonals will be not only cutting each other perpendicularly, but they will be bisecting each other perpendicularly. So this will happen. So again, you can see over here that this triangle, this triangle, this triangle, and this triangle, the triangles 1, 2, 3, and 4 are congruent triangles. Okay, they are identical triangles if you fold them into each other. So this is like something well known from your 9-10 geometry. Okay, so just make a note of this, then we'll see how this applies in vector algebra. What this means in terms of vector algebra. So you should remember these three properties. So what we are going to see in vector algebra based on this will be completely derivation from these three properties. We completely derive the logic from these three properties. Okay, so you can see the corresponding properties which I have shown in the diagrams. Okay, so completed this. So let us see the implication of this on vector algebra. So in terms of vector algebra, let's understand what each of these properties mean. So if magnitude of E is equal to magnitude of B, so that means that the vector parallelogram formed by A and B is a rhombus. So the moment that happens, it will imply that the sum of A and B will be perpendicular to the difference of A and B as vectors. Okay, because diagonals of a rhombus are perpendicular. Okay. So first thing it will mean is this. Then angle alpha will be equal to theta by 2. Yeah, square is a special case, but okay. And beta will be equal to 90 minus theta by 2. And this happens because the diagonals are angular bisectors. Okay, so when I make the vector diagram, this will become clear to you. And third, magnitude of A plus B will become 2A cos theta by 2. And the magnitude of A minus B will become 2A sin theta by 2. So this will come from the trigonometry of the congruent triangles cut by the diagonals. So I'll explain all three in terms of the diagram. First, just note these down. Okay. So these are three important properties in terms of vector algebra. Three properties I give you geometrically. So each of them correspond to three important properties in terms of vector algebra. That A plus B is perpendicular to A minus B. That the angle made by A plus B, that is alpha with respect to A, becomes theta by 2. And the angle made by A minus B with respect to A becomes beta, which is 90 minus theta by 2. And that the magnitude of A plus B is equal to 2A cos theta by 2, where A is the magnitude of each vector and theta is the angle between them. Theta is the okay. So square, Dushant, has the unique property that it satisfies the conditions for a rhombus as well as a rectangle. So square has overlap of all these properties. And the first set of properties we saw for rectangle, as well as this set of properties we are seeing for rhombus. Square may all these properties become true, because square is basically, you can call a square as a rectangle which is also a rhombus. Okay, so let us understand how each of these properties are working out. Okay, so they're very easy to track actually. So just imagine now these are two vectors which are at some angle, but they are same in length. So this is vector E. It has a magnitude of A that is equal to the magnitude of vector B. So magnitude of B is equal to magnitude of A is equal to capital A, which I'm writing. And this is the angle theta between them. So now you can immediately see that when we complete the rhombus here, I mean when we complete the parallelogram, that parallelogram will automatically become a rhombus. So if we apply the properties of the rhombus that we've discussed earlier, we will get the relationship between the vectors that we were talking about earlier. So let's look at those particular properties. So let's try to make as accurate a diagram as possible without going to actual measurement and all that. So this looks reasonably accurate. So this is the vector E minus B, this one pointing like this, and this one here is the vector E plus B. Now let's look at all the properties. So we know that this angle is 90. So first of all, we can see that E plus B is perpendicular to E minus B. Okay. If and only if, okay, magnitude of A is equal to magnitude of B. So not only this is something that we understand in this diagram, but we get the necessary and sufficient condition. ये कब होगा? Only if the sides are equal. Only in the case of rhombus. Okay. Otherwise, it will not happen. If A is not equal to B, then they will not be perpendicular. Okay. Then second thing we can see here is that this angle will have to be this angle. Okay. So this angle is how much? Alpha. Na? So this is also alpha. So alpha has to be equal to theta by 2. And again, this is if and only if magnitude of E is equal to magnitude of B. अगर ये दोनों sides equal नहीं है, then this diagonal is not bisecting the angle theta. So alpha will not be equal to theta by 2. It will be some different kind of angle. Okay? And now you can take any of these right angle triangles. For example, if you take this one, you can see that this angle and this angle have to be equal. And you can see that beta has to be equal to 90 degrees minus alpha, or beta has to be 90 minus theta by 2. And again, it is for that same condition. All these conditions are happening uniquely for the rhombus. Okay. And the final thing you'll see is that, so I will just make that in a separate diagram so that we don't get confused in the diagrams. So I'm just making a larger diagram to make this very evident. Something like this, let's say. Now let's talk about the magnitudes of A plus B and A minus B. How we'll prove that they are 2A cos theta by 2 and 2A sin theta by 2. So for that, we will have to use the fact that the diagonals bisect each other perpendicularly. So they are forming, equal. They're forming these congruent right angle triangles. These are all 90 degrees. Okay. And now this is bisected. So let us say this side is x. So this side is also x. And this is also bisected. So let's say this side is y. This side is also y. And of course, this total angle was theta. This side was equal to this side. It's capital. Now see any one of these triangles, like see the one that I'm shading over here. Just look at this triangle which I'm shading. So in this triangle, you can see that this angle is alpha, where alpha is theta by 2. So now in that triangle, you can see that cos alpha is x upon base upon hypotenuse, and sin alpha is y upon e. So automatically now it implies that x is equal to e cos alpha, and alpha is theta by 2. Implies that y is equal to e sin theta by 2. And 2x, the sum of these two, is nothing but the magnitude of this diagonal. And 2y similarly, the sum of these two halves is nothing but the magnitude of the other diagonal, which is mod a minus. From here, it becomes very obvious that mod of a plus b in this diagram should be equal to 2x. So mod of a plus b is 2a cos theta by 2, and mod of a minus b is 2y. It implies that this is now a shortcut formula that we have. This is extremely useful. I'll show you how this is useful also. So these two are two important properties for the special case when mod A is equal to mod B equal to capital, or the case of the rhombus. And the square is included in the rhombus. Okay? So just remember that square is a special case of rhombus, but rectangle is not. A rectangle may be a square, may not be. So start from here. Start from this thing. Understand these angles. The first 2 points you understand. Then we come to the third point: the magnitude of a plus b and the magnitude of a minus b. right? So now this is the part which is a little complicated, because first of all you are understanding the trigonometry of the four. I mean, first of all, you're understanding the angles are alpha is theta by 2 and all that. And therefore, you have the four uh, congruent right angle triangles. And then you're finally applying trigonometry to any one of these four triangles. So, first of all, this x and x are equal, y and y are equal because the diagonals bisect each other. Then, secondly, these all four angles are 90 because they bisect each other perpendicularly. And then finally, you're using trigonometry to any one of these triangles to find out x and y, and from that you're getting the diagonal 2x and the diagonal 2y, and from that you're getting this special formula. Okay, so these all represent the special properties or the special cases of the parallelogram law. You can remember the special cases as the rectangle case and the rhombus case. Now, also one more thing you should remember is the square, where magnitude of E is equal to magnitude of B, and E is perpendicular to B. In the case of this, what happens is that mod A plus B is equal to mod A minus B is equal to root 2A. Alpha becomes equal to beta equal to 45 degrees, and A plus B is perpendicular to B minus B, because a square satisfies the properties of both rhombus and rectangle. The square is like an ultra specific kind of this. So all these three properties. Okay, so let us understand some questions now. Or let's work out some questions where we can make use of this. But before that, this formula that we had, by the way, this formula that we had, that if mod A is equal to mod B. Yes. Oh, Arvinda, sorry, I didn't see your doubt. Both pairs are equal. I'm just coming back to this diagram. यहाँ पे ये दोनों angles equal है ना, तो ये दोनों भी equal. These are also equal. This is equal to this. And likewise in this triangle, this is beta, beta. All these pairs of angles are getting bisected. This are alpha. That I didn't put in this diagram, but it's understood. That was your question. Okay, so now coming back to this. So this thing that we have, that if mod A is equal to mod B, then mod A plus B is equal to 2A cos theta by 2, and mod A minus B is 2A sin theta by 2. Now these two formulae which I have given you a geometrical proof, they can also be proved by using trigonometry formulae and triangle law. But for that you have to know this trigonometry formulae. I'll tell you which one you have to know. See, you know that cos A plus B is cos A sin B. Sorry, cos A cos B minus sin A sin B. You're familiar with this one? Have you done this in trigonometry yet? This formula? पढ़ा है ना? Okay. And similarly, yeah. So similarly, cos 2A becomes, yeah, there is a new study. This cos square A minus sin square A. Similarly, sin 2A becomes 2 sin A cos A. So these kind of formulae we are going to make. So let me show you how we are going to make it. So in the formula, yeah, magnitude of A plus B is equal to root of A square plus B square plus 2AB cos theta. इसमें condition put कर दो that mod A is equal to mod B is equal to Q. Okay. In other words, B's magnitude is equal to A. Just substitute that over here. So mod of A plus B will become root of A square plus A square plus 2A square cos theta. We can take A common. We have 2 plus 2 cos theta. One plus cos. Now this is where we will make use of this formula, this one. So how we make use of it? I'll show you. Cos theta can be written as cos square theta by 2 minus sin square theta by 2. And further, it can be written as 2 cos square theta by 2 minus 1, because sin square theta by 2 can also be written as 1 minus cos square theta by 2. So substitute this over here and we get this. So we'll make use of this. So cos theta can be written like this. So if you substitute this here, this becomes E into 2 into 2 cos square theta by 2, because that 1 cancels out. So now this becomes 2A cos theta. So that is your proof that mod A plus B becomes this. When we apply the condition that mod A is equal to mod B, that is A and B are of equal magnitudes, then the triangle law formula, that root of A square plus B square plus 2AB cos theta, that itself can reduce to 2A cos theta by 2. But for that, you have to use these trigonometric tricks or identities. Now, likewise, you can do the proof of the second formula also, that mod of a minus b will become 2a sine theta by 2. By a very similar method, you can do the proof of that also. So you can write this down and try that out yourself. Okay, so just scrolling up for a moment, what I'm showing you here is that these two special formulas, this one I have to, this one you still have to do. So these two can be proved by using trigonometric formula along with triangle law. So I've done the proof of the first one, that mod a plus b becomes 2a cos theta by 2. Similarly, when you finish writing this down, you can try out the second one yourself. Okay, so understood the proof of this now. Now, similarly, try to prove this other formula yourself. Now, try to get this proof. If magnitude of A is equal to magnitude of B. Very similar kind of method. Try to use that. Okay, so hope you got this. So here you just use the formula mod A minus B. Good, good question. Root of A square plus B square minus 2AB cos theta. In that you put the condition. Very good, friends. So यहाँ पे put B equal to A. So next step this becomes E into square root 2 into 1 plus cos theta. Now यहाँ पे put cos theta as cos square theta by 2 minus sin square theta by 2. And so you want to get rid of the 1. So you want to make this as 1 minus this will be 1 minus because it's the E minus B base. So write this as 1 minus 2 sin square theta by 2 instead. So that you can get rid of the 1. This is using the fact that cos square theta by 2 is 1 minus sin square theta by 2. So put that here. So that will be this step. Cos theta can be expressed like this. Now substitute this thing here and you will get what we're looking for. Let this as 4. So this proves this. So this is the trigonometric way of proving it, which otherwise we had shown by geometry, which is by the way much more convenient as you can understand. Okay, now next up, let's look at a couple of questions based on this. Now my next example is like this. Given that magnitude of E is equal to 2 root 3 and magnitude of E plus B is equal to magnitude of E minus B is equal to 4. So find magnitude of B theta, the angle between E and B, and also alpha, that is the angle made by the vector sum of A and B with respect to E, and beta. Very good, Aman, that is correct. The angle made by E minus B with respect to E. Yes, Aman, you got this correct. Good. Now quickly calculate alpha and beta also. You got the first two things correct. All right, so hope most of you got the answer from this. Yes, very good. So you can immediately see that mod A plus B is equal to mod A minus B. It means that is the rectangle case. And that means theta is equal to 90 degrees. And mod A plus B is equal to mod A minus B is equal to root of A square plus B square. And that is given to me in the question as 4. So substitute that over here. And this is given as this, so substitute this over here. So root of 2 root 3 whole square plus b square is equal to 4. So 12 plus b square is equal to 16. So b square is equal to 4. So b is equal to plus minus 2, but here b is magnitude of the vector b, so we can't take minus 2 in this case. And then you understand that correct, still the angle is correct you given. So now you can see that your rectangle is looking like this basically. This is 2 root 3 vector A, and this is 2 in magnitude vector B. So now this is A plus B, magnitude 4, and this angle is alpha. And this is A minus B, also magnitude 4, and this angle beta is equal to alpha. So you can see that alpha will be equal to beta, will be equal to tan inverse of this side by this side, that is 2 upon 2 root 3, or tan inverse of 1 by root 3. That is 30 degrees. That will second. That alpha is equal to beta equal to 30 degrees. Of course, beta was 90 degrees. So you could have done this by using the formula-based method also, but you can see it's so much more convenient to visualize it. It becomes a very simple thing to solve. You don't have to keep applying so many formulas, substituting so many things. So that is the advantage of knowing these special theorems. Your problem solving becomes faster and more efficient. Okay. So now that you are familiar with all the basic concepts and the application of basic formula and all that, now you can start adjusting with these special tricks and all in solving questions. Next example we'll see the quick application. So given that magnitude of A minus B is equal to root 3 times magnitude of A plus B, and A minus B is a vector quantity, is perpendicular to A plus B. Okay, this is given to us. So we have to find, first of all, Okay, so start working on this question. Anybody got the answer? Arvinda, थोड़ा सा साइन का प्रॉब्लम है. थीटा will not be 60 degrees. Just check the algebraic signs in your solution. Might be a mistake with that. So one of these is So if you just remember this situation, then it's very useful. Remember that, yes, correct. Aman, that is correct now. A plus B is perpendicular to A minus B. That immediately that should ring the bell that the parallelogram is a rhombus. First of all. Now recall all the properties of rhombus. So mod A is equal to mod B. Okay. Alpha is equal to theta by 2, beta is equal to 90 minus alpha by 2. And most importantly, magnitude of A plus B is 2A cos theta by 2. And magnitude of A minus B is 2A sin theta by 2. So if you make this connection immediately, you will, yes, Aman, that's correct. Okay, then you will be finding this very easy to solve. Now, given the question is that not only A plus B is perpendicular to A minus B, but also it is given that mod of A minus B is root 3 times mod of A plus B. So now to make sense of this in terms of the relationship between the vectors A and B, okay, so this thing that the diagonals are perpendicular, this has already told you this thing that the vectors are of equal magnitude. This connection you've already made, and now these formulae you can substitute them over here. So that will give you the unknown angle theta. So 2A cos theta by 2 is becoming root 3 times 2A sin theta by 2. So this is telling you that tan theta by 2, if we just cross multiply, is equal to 1 by root 3. Oh, sorry, it's the other way around. My mistake. This one is A minus B, so this should be sin, and this one should be cos. Just make a correction here. So this one is sin, and this one is cos. So it's root 3 in fact. Just be root 3. So theta by 2 is tan inverse of root 3, which is 60 degrees, or pi by 3. So that's showing us that theta is 120 degrees, or 2 pi by 3. So ultimately now we are realizing our rhombus, I mean, though the diagram is not required, this is enough to solve the question, but you'll also understand the logic of the question by visualizing the diagram. It's an obtuse angle between A and B. And so that is why it's the secondary diagonal, which is A minus B, which is longer in comparison to the primary diagonal. So this theta equal to 120 degrees. Yeah, Prince, I'm coming to your doubt, just a second. My diagonal will be looking so you can see that this is your A plus B, and this angle is equal to this angle, alpha will become 60 degrees. This is your E minus B. They bisect each other perpendicularly. All that. Okay. So your beta is equal to 90 minus theta by 2, or 30 degrees. Okay. So this angle is equal to this angle, which is beta. Okay. And now you can just cross check what is happening over here. You can cross check that your A plus B will be 2A cos theta by 2. So that is 2A cos 60. So that will be E, because cos 60 is half. Whereas E minus B will be 2A sin theta by 2. So that is 2A sin 60, which is root 3. So you can see that this is satisfying this condition that was given to us above about the problem. It's satisfying this condition. So you can check that this thing giving us this relationship. Okay, Aman. Sorry, Prince, you understood this now. Mod A minus B is equal to root 3 times mod A plus B. That is given in the question. But we have also understood from the rhombus theorem that when these diagonals are perpendicular, what is mod of A plus B? It is 2A cos theta by 2. And what is mod of A minus B? Okay, whenever we have the rhombus case, you have the direct formula that A plus B has a magnitude of 2A cos theta by 2. And A minus B has a magnitude of 2A sin theta by 2. So you just substitute that in this given condition. So that is giving you the condition on theta. That's showing you that you are looking like this. So you can see that compared to doing this algebraically, you can save a lot of steps by just using these direct formulae. This whole thing is just to check. This was not required. The problem was done when we completed these steps up to here only. Here the problem is over. Now you can see from this that A is to B is obviously 1 is to 1. Okay. Mod A plus B is 2A cos theta by 2. So that is equal to A over here. So also A plus B has the same magnitude as B. But similarly A minus B has the magnitude of root 3 times E. So this is happening because of the special case, because theta is 120 degrees. And you can also see that alpha will become 60 degrees, beta will become 30 degrees. So once you just come to this solution, the question is over, because now you're coming to these steps. So all the different parts are coming from this. Okay, so I understood the advantage of using this method. Yes, and that alpha is equal to 60 degrees because alpha is theta by 2 and beta becomes the complement of alpha. So that picture should be fixed in your mind of the rhombus and its properties. Then questions like this you can do very fast. And when we are doing in future chapters, when we are doing chapters, we are doing applications of vectors and all. You'll see that these little tricks come in very handy. Okay. For example, suppose we have a question like this now. We have a situation where 3 forces are acting on a body. So on some particle, there are forces F1, F2. This angle is theta. And another force F3. Acting like this, where this angle is, let's say, alpha, and this angle is, let's say, beta. Now, given that the resultant of the 3 forces is equal to 0, okay, and F1's magnitude is equal to F2 equal to 10 newtons, and theta is equal to 60 degrees. So find magnitude of F3 and alpha and beta. Okay, so just try this out. Very good. That is correct. Okay, that's correct. Alpha and beta will be symmetric. So here you can understand very easily that f1 plus f2 plus f3 is equal to 0 implies that f3 is negative of the vector f1 plus f2. Okay. So now let's just concentrate on this thing. Okay, so if we concentrate on these two, f1 plus f2, you'll realize that they are forming a rhombus. So this is 10 newtons, this is 10 newtons, and this angle is 60 degrees. So their vector sum should become like this. Their vector sum should become like this. This is f1 plus f2. It will be such that this angle is equal to this angle equal to 30 degrees, and its magnitude will become 2 times 10 newtons into cos 30 degrees. So that is 2 into 10 into root 3 by 2, or 10 root 3 newtons. So this magnitude is 10 root 3 newtons. Okay. So now we can see that since f3 has to be minus of f1 plus f2, it has to be just equal and opposite to this vector. So f3 in this diagram has to lie exactly diametrically opposite to this and of same magnitude. So f3 has to be like this. This has to be 10 root 3 newtons in magnitude, such that now this angle is 180 degrees. Okay. So there, as is this angle. Okay. So therefore, what is these two angles, alpha and beta? They are symmetric. This angle and this angle, okay, alpha and beta, is 180 minus 50, or 150 degrees each. Okay. And magnitude of f3 is equal to 10 root 3. So solving a situation like this becomes quite simple, other than when you have a cat who decided to jump straight onto the board. Anyway, hey. Okay, people. So is it clear? Is the calculation clear, people? Okay, people. Fortunately, I'm having some difficulty with my internet connectivity. So my whiteboard screen has gone off. Just have to check. So it's almost time. So we'll wind up here today, and I will send you some additional questions. So try to work out maximum. Yeah, it's visible, but actually I'm not. It's stuck actually. So you can see now that laptop has actually lost its internet connectivity. I'll have to reboot the system. Sorry about that. So anyway, it's raining very heavily here. Maybe that's why the internet is slow or something. So anyway, we'll wind up here for today, and I will send you a list of questions to do from the exercise, module exercise, okay? And you can complete those, and next lecture we will start with the scalar product and the cross product. Okay? So we'll start with the products of vectors. Now we are done with all these operations, sum, difference and all these, and component algebra, and you understood components in 3 dimensions also before this. So just do a revision of that. And I think in the last lecture I had covered all your doubts from the test paper also, right? If I'm not mistaken. Yeah, so that being the case, okay, should not be difficult then. Okay. Yeah, so that was done. So just okay. So yeah, after dot product and cross product we'll complete vectors, but it will take some time. Dot product and cross product together will take about 2 to 3 lectures. So it's still some time remaining in vectors. Okay. So most of the questions which are to do with sum, addition and all that you can complete now from the exercise. I'll send you a list of questions. So that will be your homework for the upcoming lecture. Okay, that's it for today, people. Thanks.